Hey guys, so today I'm going to be starting a new topic on radioactivity, and first I'm going to be talking about atoms and radiation, okay? So, first of all, if you want to look at radiation, especially background radiation, but any type of radiation really, you can use a Geiger counter, okay? Now, hopefully you will have a demo at school that can show you this, but if it doesn't, I'll have an activity or an animation that tells you how it works. So, a Geiger counter can be used to detect radioactivity, any type of radioactivity, and the counter clicks and records a number each time a particle of radiation from a radioactive substance enters the Geiger tube, so the detector, okay? And just so you know, a radioactive substance gives out radiation at all times. So this is how it looks like. This animation is not mine. So this is how it looks like. I have here the Geiger counter. This is where you can see, you hear the click and you see the number of radiation going up, so the number of radioactive particles detected coming up. This is the actual detector, okay? And the detector is detecting every time there is a particle, in this case this is an alpha particle, goes in, enters the tube, okay? So this is radiation that is ionizing, meaning that it kicks off an electron of an atom and produces an ion, because an ion is an atom without with a charge. So because it's ionizing, meaning that the atom, instead of having neutral charge, the same number of protons and neutrons, has more or less number of electrons, making it have a positive or negative charge. That's an ion. The Geiger counter picks up ionizing radiation, okay? So radiation that kicks off an electron and can produce an ion. So that's how it works. Now, if you use a Geiger counter, you figure out there are three types of radiation, okay? It could be alpha radiation, beta radiation, and gamma radiation. Now, alpha radiation, or actually all of them, have the Greek letters, the symbols for, this is the Greek letter for the alpha, this is the Greek letter for beta. So alpha looks like a fish, beta looks like a big bee with a big leg or tail, and then this is the symbol for gamma. There's not much I can tell you about it. So this is how you should represent them, with the Greek letters. Now, this table in here, this diagram, is the whole thing summarized for you. I will get into more detail. But alpha is the least penetrating of all radiation and is the most ionizing. Beta is in between, and gamma is the most penetrating of all and the least ionizing. So in terms of ionization power, you already know. So is how much energy they have and how easily they can kick off an electron of an atom and produce an ion, because again, an ion is an atom with a charge. So that part you know already, but I will give you more detail in another video. In terms of penetration power, well, you can put different materials in front of the Geiger counter, in between the radiation source and the tube where you detect the radiation, and you can see what can stop this type of radiation. And if you do, you see something like this. And again, this particular PowerPoint slide is not mine. So alpha, which is the largest particle, alpha is made of is the helium nucleus, so it's made of 2 protons and 2 neutrons, have an overall positive charge. It's quite large. It is stopped by paper, okay? Beta is a fast-moving electron, so negative charge. Beta passed through paper, but is stopped by aluminium, a thin piece of aluminium. Gamma is an electromagnetic wave, has neutral charge, so not positive or negative. It's just pure energy passing through. It goes through paper, aluminium. The range is, you know, infinite. It's only absorbed by lead, thick lead or concrete. So in terms of ranges in air before they are absorbed, alpha is a couple of centimeters in air, beta is a couple of meters, gamma, again, how you get energy from the sun, for example, is an infinite range. More on that as well to come, okay? So this is all that you need to know in the table about how they work, okay? So of course you could have freeze the video or pause the video to try to get this table done yourself, but this is what you should know. Symbols, alpha, beta, and gamma. Penetrating power, alpha the least penetrating, gamma the most penetrating, beta in between. Stopped by alpha, a few centimeters of air or paper, beta meters in air or a thin sheet of aluminium, gamma thick lead or concrete. In terms of ionizing effect, so how easily they can kick off an electron and make that atom to be an ion. Alpha is the most ionizing, beta is in between, and gamma is the least ionizing. This means, and this is quite important, that alpha is the most dangerous for you to have around near you or inside your body because it's the most ionizing. And I say near you because is stopped easily or is the least penetrating. Gamma is the worst for you to have outside your body or at long distances because it's the most penetrating. It will pass through your body, okay, but it is the least ionizing, okay. However, if it passes through your body, that ionization is going to get to you, while alpha doesn't pass through your skin. Okay, again, more on this topic. There are going to be a couple of lessons where you need to know more in detail this part. Finally, why do I get this radiation be given off? So this radiation is given by atoms that we call them radioactive, okay? So some atoms, they have a particular combination of protons and neutrons that make their nucleus unstable. This has to do with the electromagnetic force and the strong nuclear force, but you get to know, actually, if you go on my A-level videos on particles and radiation, or particles and antiparticles, I explain this. So it's actually called something like radiation or decays or something like that. Go there. So the atom decays to become more stable, okay? So it emits energetic radiation and the nucleus changes, okay? So it will give a particle or some particles. So this happens only once, and then the new atom that I have there, or the new isotope, may decay again, okay? So this is called radioactive decay. It's a random event. I know it will happen. I can predict how many particles are going to be given off in a certain amount of time, but it's completely random in terms of when the decay is going to happen, okay? And this is how it looks like. So this is my nucleus that is quite unstable. Radiation is given out in form of energy and a radioactive particle, which could be alpha or beta, okay? So this is all that you need to know for now. More detail on this stuff is going to come up to my next video. Be happy and healthy. Bye!